Today, I'm going to tune the car that had the Cobb FA intercooler on it. So, I'm not tuning it from scratch. I'm not going to tell you everything that I'm doing because that would take a long time. I'm starting with a map that I've already done, so it's got a lot of the little things already done in it. One of them is the full-time closed-loop fueling. From the factory, these don't have full-time closed-loop fueling. They only do it like the EJs would do it at low loads and and very light boost. So since the O2 sensor is post turbocharger in this car, in the FA WRXs, and it has a really wide band of operation, thus wideband, it's really easy and conducive to enable or to tell the computer basically to run closed loop full time. What's up, buddy? You're good. Oh yeah, looks good. I like it.
Weird.
Yeah, I'm a fan.
You're a fan?
Yeah, I like organized. If you ever were to MPS in the day, you'd understand why. Yeah, please. So this has got the closed loop fuel time enabled on it. It's got a Cobb SF, EBCS, and that kind of stuff. So yesterday, I believe I talked about the boost control on the FAs, how they tend to spike and then not try very aggressively to maintain boost at the target. And so this already has the changes that I make to the turbodynamics to make it actually chase the target like it should, and hopefully mitigate the huge spike that they get. Like you may have seen if you were on the video yesterday that we were hitting 23 pounds of boost on some of those poles, and that's way more than this car technically should run. It's way more than it was programmed to run, and so the turbodynamics controlling it wasn't quite up to par in my opinion. So that being said, overall I think the OTS maps for Cobb are really good. I just think that there's still refinement left, but that's fine because that gives us tuners something to do, and they can only tune the car or make it tuned for a car with specific modifications, and that's why it's really important if you run an OTS map that you're following the modification guidelines associated with that map. The most important being the intake, and then the second most important being the exhaust. And some people think that's wrong, but it's not wrong. That's absolutely correct. The intake is the most important component. It must match because every calculation starts with the mass airflow sensor. If the intake is off, then everything is off from there. Every load calculation, everything. So fueling, timing, everything will be off. So if you're one of those guys, for example, that has a 2015 plus STI, you have an exhaust and intake on your car, and you notice Cobb doesn't have a map for stage 2 with their intake because of their concerns with the fuel system, then do not run the stage 2 with the stock intake map. That is 100% wrong. Do run the map for the SF intake. And if you can find it, run the low wastegate duty cycle map. That'll help compensate for the reduction in back pressure that the boost control system is seeing, and make the car run safe. You run the other map, the car will be unsafe. It'll be lean, it'll be dangerous, it'll have too much timing. That is not the way to do it. So just because you have an exhaust and intake, and you say, oh, it's stage 2. No, wrong. You gotta match the intake. It doesn't fucking matter if the exhaust is cut off with the turbo. You gotta match the intake. You put garbage in the calculation, you're gonna have garbage out of the calculation. And the most important part of the calculation is the intake. It's the very first step. Other than establishing position of the engine with crank and cam sensors, the next step is how much air is going into my engine, and that is by the mass airflow sensor. So if it's wrong, everything else is wrong. So anyway, so today I'm gonna do the tune on this car. It did not exactly meet the specs of the Cobb map that is on it. It does have the Cobb SF and it has a Cobb SF map, but the exhaust and EBCS do not totally match the Cobb map, and as such, we had some weird issues with the power curve and a few other things that this car was doing yesterday. A massive dip. Pretty much every pole, I'll show you that. I'll show you. Every freaking pole had this really bad dip. That's usually where peak horsepower is. This thing should carry, right? And then dive a little bit, because an FA, they drop pretty hard after 65 towards 7. You got to work really hard to get the whole power to 7, but that shouldn't be there at all. And can you even see that? Sorry if I'm not showing. There you go. That shouldn't be there at all. So we're going to work on that, and a handful of other things. The ComTune did a good job maintaining boost once it had stabilized, but it still had a spike and was going over target. So we're going to address the spike and all of that today. So I got my bass tune. I'm working on it right now. And then in a minute, I'm going to turn the camera around and we're going to just drive in the car on the dyno and all that stuff. Chase up this GoPro in the car. It's sitting right here on the dash still. But let's make sure this is set. I'm going to do a flash on. The car's cold, so it's got to warm up. But I wanted to put my warm-up timing strategies and fuel strategies in it, and idle control strategies in it, so that it was a quieter, more reasonable warm-up. When I first fired it up cold on the map that's on it, it was flaring to almost 3,000 RPM, and it was hunting from 2,000 to 3,000 on cold start. And some of these FAs do that. Obviously, it's not what we want this thing to do. So I've got a different cold start strategy that I do on these, and I'm going to put that in here in a few minutes too. I was just working on the closed loop fueling and some other stuff like that. So again, since I don't want to start from scratch, I'm going to borrow some from another tune, and then I will go in and check each table and verify that's where I want it to be. But these cars have so many tables. Holy crap! Let's see if I can show you this. Okay, the FA has so many tables that there's folders. Well, I can use real time because it's located in other places. So there's folders with tables, and sometimes there's folders with tables. All right, here's folders with tables. That one's only got one. That one's got a bunch. All right, there's so many tables in here. Even the cam position has got layers of folders in here. So these cars take a very long time to tune if you start with the factory ROM every time. And I mean, literally, I could spend a couple hours just going through these tables and changing them, because there's a lot that changes from stock. In fact, if I take this right now and I go compare to stock, 205 tables have differences from the stock map. So 205. Can you imagine going through 205 tables, most of which are three-dimensional tables, and changing everything every time from the get-go? That's a lot of damn work. And so where I can, I will borrow some of my work from other tunes, and then I go through and verify. But if you do what you're supposed to do when you tune these cars, you leave notes behind so you know what each tune is. And Cobb's really cool with that, because it's got this section here, and I'm still filling it out now, but it's got a section here for the modifications. So far I wrote into those SF, EV, boost control solenoid, and throwback exhaust. I'm going to write the intercoolers on here too. And really, it doesn't have much more than that. It still has its TGVs, it still has its EGR. That's it. So luckily I don't have to do a very long one there. You see here I got 91 octane, so that's what it's going to be running. I put the owner's name here too normally, and I will when you're not looking, because it's none of your business. I think it's just for the privacy of the owner. And then they have this option. They recently added reflash only. That's so you can't change real time. I'm enabling that here because I'm not making him multiple maps, and so I don't want him to try and flash a real time from somebody else's tune on top of this and have it not be compatible with the reflash values that are in this tune. Fuel tables. I haven't got the fuel tables yet, right? Look at this. Maps on maps on map. Oh, they had folders with folders. Right, there's just so much in here. The Cobb is so thorough and so in depth and complete compared to a lot of the other suites. I mean, there's just so much in here. And yeah, anyways. Oops, there we go. One thing I also do differently is I put the rev limit back down a bit. Some tuners and Cobb included, when my face is on fire. There we go. Tend to raise the rev limit to 7,000 RPM. I've had a lot of issue with that. I've seen a lot of cars bend rods or fail, shoot out rockers, break valve springs at that higher rev limit. So I only raised it 100 from factory, and that's it. I don't put it any higher than that. There's no point on these factory engines to do that. One, they don't make any freaking power up there. Their power's diving hard. The The rod ratio is even worse on these than it was on the EJ. It's really, really difficult to maintain power on the top end, especially the factory turbo when it's out of breath and everything. So there's no real point in pushing them up there. You're just, in my opinion, the risk is not worth the reward, because the reward is freaking minimal and the risk is really, really high. So I don't push it even as hard as Cobb does in the RPM for the limit, as far as that's concerned. All right, so got the math calibration in here. That's the most important one. I'm going to verify startup stuff. So startup stuff, again, it's got, dropped my phone. Startup stuff, it's got lots of parameters that affect the way the car runs. So in the fuel tables, I'm sorry, I don't do it in ignition tables. The most obvious ones are the timing during warm-up. Now, a lot of people don't mess with this map enough, and they get the really loud stratified start, or they adjust the map too far, and they get a car that rev hangs really bad during start, and yeah, so it helps to adjust this table here. And then here with coolant temp, not that one, sorry. So, oh yeah, so stratify, that's the big one. Primary for idle control. If they do TGV deletes, you got to add a little bit to idle. This one does not have them, so I'm taking that extra time back out because I don't need that anymore. The stuff I borrowed was from one that had that, so I don't need that to be the case. These are the main timing tables. You'll see it's got more across the board than the factory table here in the main one, but then the dynamic advanced tables have less than the factory. See there, it's got 3 less in that range, and then 4 to 6 less there. So we run a little more on the base and a little less on the dynamic advance with these. Closed loop target, this is where you change everything for the closed loop fueling. You can actually go through and do, let's take it off, compare so you can see what this. So you can go through instead of oops, wrong one. I wanted to go to transitions here, sorry. So transitions, you got the delay. If you set the delay to nearly infinite, then it'll never go open loop. And that's one of the first steps of doing it. And then you have to go through all the load settings and everything else to get it set up so that it will stay closed loop. Anyways, so that's done. Okay, so I'm gonna save this as the base map. I'll put his name on it at the end of the tune so you guys don't catch that. I'm gonna flash this one, and then we're gonna see how it starts. So do that. No valid amps were found. Well, let me double check that I did the correct serial number in there. Double check the Cobb serial number for the Accessport. I swear I did it. 426254. 426254. That's correct. Okay. So I don't know. I hit save. I need to do that. Then I need to. Maybe this port needs to be updated. That could very well be. I didn't check the update on this. Yep, new firmware. Oh, long time ago too. So it definitely has some firmware to be added. But before I do that, yeah, I'll do that now. All right. So that's why that didn't work. We got to update the firmware on the Accessport. And any tuner that's done this crap knows that that is often a prerequisite, because Cobb updates the firmwares a lot. They're always adding features to the software, and that's wonderful with Cobb. They're always adding it, and that's one of the big reasons why I prefer the Cobb suite over anything else. They have people you can talk to. They have a Facebook group. They have like eternal support for the product, unless of course it's a the BMW, and they're not doing that anymore. Then your SOL or an 18 and up GTR, for some reason they're not doing that anymore either, which I think is really bizarre. But you got to go to ECU Tech for that, unfortunately. I just really prefer the guys at Cobb over ECU Tech. ECU Tech, they're so freaking full of themselves, it's hard to deal with. But Cobb guys are definitely way more down to earth and way better to deal with. So firmware's updating. Not much I can do about that. Anybody got any questions right now? I can answer questions while this is updating. It's always pretty good. Again, any question at all? Life, maybe a little never have I ever, you know, whatever. I don't care. And I clicked, this video is not made for kids, so feel free to say what you want. Anyways, I'll just recap yesterday. Yesterday, we tested the Cobb top mount intercooler. I did a handful of tests. I did tests to show how good the intercooler is for short bursts over the factory one, and we found out that it was indeed quite a bit better than the stock intercooler for things like drag racing. But then we did longer pulls, and we discovered that in a track type scenario, the factory intercooler would most likely excel over the stock intercooler. Right, stock intercooler would excel over the Cobb intercooler in something like track racing, and in my opinion, daily driving. The Cobb intercooler showed that it had the ability to absorb a lot of heat out of the intake charge, but that it also had a difficult time taking that heat and giving it out to the atmosphere. And that's what you would expect with an intercooler of this construction. So, okay, I saw the first question come in. What do we got? Sorry, I clicked on it. It said, is feedback knock okay and fine knock run okay if it's not too high of a number and my dam doesn't move? So short answer is yes. And honestly, your dam can move. It doesn't fucking matter. For some reason, the internet thinks that when the dam moves, that all hell broke loose and your engine's done for. That's actually not the case at all. The dam is supposed to move. From the factory, the dam moves a lot. The dam is technically more of an octane measurement than anything else. It's set up so that if the car sees low octane, the dam drops to cover, protect the engine. If it sees high octane, the dam goes up. So if the dam drops, so fucking what? What does that mean for you? It means that at some point in time, the ECU thought that it saw something, an indication that thought that the octane was low. And so it pulled some timing. And what does that mean for you in the end? It means that your engine protection strategies are fucking working. So yay, that's good. And then two, it means that you've lost a little power up top. That's what it means. You're gonna lose some power. Now, if your dam is continually dropping, and you got the same octane as the tune, and you go to the same gas station, then it's possible something has changed since the tune, or potentially that the mass airflow sensor calibration was off a little bit, and you have a learned parameter, or a learned parameter basically that has thrown off the fueling in open loop. So on a 13 WRX, there is 4 learning zones, 0 to 5, I think it is 5 to 10, 10 to 30, and 30 and up, or it's 10 to 40 and 40 and up. It super changed them a little bit based on the years, but those are the general zones. It's basically low idle, high idle, cruise, and acceleration out of boost, like a moderate acceleration. Those are kind of the 4 zones. But the last one, zone D, the final one, that one is applied to open loop. So if for some reason the MAF calibration was off, and in that higher load from up to 40 or whatever it is, then it's possible that if it learned to pull fuel, then you're now running lean in boost, and also you'd have more timing. So both of those may induce knock in the future. And so it's possible that MAF calibration needs to be adjusted a tiny bit, or that you have a leak of some sort, or the day you got the tune done, the fuel was really good, or that your tuner was just too aggressive, right? So things like that could cause those things to happen. But does it mean that your engine's blown up? No, of course not. Doesn't mean that everything is broke. No, I'd be more concerned if you have knock and your dam doesn't drop. I would prefer the dam to drop, because that means it's making global corrections in an attempt to save the engine, than for it to have knock and dam not drop. That would concern me more. Now, if it's negative 1.4, which is for most tuners, that's the first step, then so what? Also, the most important thing to know about knock is the context at which it happens. If that knock happens at idle, if it happens during a rev, if it happens you're leaving a stoplight and like under 2 pounds of boost, so what? Don't give a shit. Because honestly, knock is only as strong as the amount of air and fuel that's left in that cylinder when the knock event happens, right? So if I'm in cruise, I'm on the freeway, I'm making 20, 25 horsepower, cruise on the highway, and it throws a couple knock events or a couple knock counts, don't give a shit. Like, your duty cycle is like 8, right? 8%. And knock doesn't even happen until like 65 to 80% of the air and fuel in the cylinder is already burnt and you're near peak cylinder pressure. Then knock occurs when the rest of it starts to collide, starts to ignite and go across the front. So how much power is there in 2% of your total injector power? Not much, right? Not a whole lot of BTUs in that fuel. But if you're at full throttle and you're at 80% injector duty cycle, now we're talking that knock has some power. So the knock is all about context. If it's happening, like I said, in cruise, happening in idle, leaving a stoplight, moving slowly, don't care. Like, don't waste your time worrying about it. It doesn't make any sense. But if it's happening full throttle, then yeah, that's something to worry about. How much worry? I don't know. Depends. Depends on how bad the knock is. Negative 141, whatever. Right? And if you get fine learned and it pops up, then all that means is it pulled time before. That doesn't mean something's going on right then, necessarily. The very first time it goes there, it could be there. But if every time you hit 5,000 RPM, you get a fine learned, then yeah, that means that's where it has learned to pull timing. It's not saying, oh my God, something's wrong right now. It says, before I thought something was wrong, and so I learned to pull timing here, and it's telling you how much it learned to pull. So, fine learned, don't freak out about that. Now, if it says -8, and it's in cruise, well, that's a little weird, but that doesn't mean anything's broken. If it's -8 and you're in full throttle, then I would be concerned. That means you're either running lean, there's something wrong with the ignition map, you got something going on. That would be the concern. So hopefully that was a thorough enough explanation for that. Let's see. Rattles too, yeah, absolutely. The FA is really bad for that. The FA WRX, it will, it says loading, but it's not working. It will trip a knock event when you turn the AC on. It's just too sensitive, right? I mean, that's obviously not knock. Okay, so let's try this again. I got the Accessport just finished its update finally. I swear, when the version 3 first came out, the updates were really fast and it was awesome. And I remember that because the V2 updates were slow as balls. But as Cobb's added features, these updates are taking longer and longer and longer on the V3. It's reminding me of the V2 days when you update it and you wait 10 minutes. All right, now it's flashing. I think it says 0. I'm waiting for a 1 to pop up. There we go. All right. So that's all it needed was an update to the firmware, and now it is flashing this map. So again, this car's cold, and like I said before, it would flare like 3 grand and sit there, and then start to oscillate between 2 and 3 during cold start with the OTS map on it. I'm hoping that mine goes to like 1800 to 22 and sits in there while it's cold and sits relatively steady. We'll see. Man, this is the first shot I get at it, and typically with cold starts, you don't get more than 1 shot in a day. So I'm hoping that I nailed it. Boy, this taking a while to flash. Okay, I know there's another question. Let me go back to that. Would those same results apply to another top mount like the green speed? Yeah, Jeremy, the conclusion that I made was exactly as I thought it would be, due to the construction of it. Now, how much better, or compared to, whereas I said that the Cobb was better than the stock one for drag racing and stuff. I don't know. I don't know how much better than the others it would be. Like, I think the grid speed would provide you similar results, but I think the Cobb, looking at it, I think the Cobb's slightly better than the grid speed one. So I don't think the results would be as good, but maybe not. The grid speed's thinner, and so the grid speed might do better on the track than the Cobb, and the Cobb would do better at drag racing than the grid speed. Again, when we're talking about bar and plate intercoolers, at that point, we're really talking about mass, and we're trying to balance mass versus airflow through the intercooler. So when we make the intercooler really thick and really big, we increase the cross section, you get a higher flow rate through it from the turbo, less back pressure, the more power potential, like airflow, you need a volume of air or mass of air to make horsepower. right? And so if the cross section is too small, you're not going to be able to flow that. So it's a big cross section, it can flow a lot. The problem is when it's really thick, the air through it from the atmosphere gets slowed down and doesn't do as well. So now you're at that point. Well, now I can make it thinner. I'll have better flow through it. It'll do a better job of taking heat and put it into the atmosphere. But now I've reduced the cross section of the intercooler, and now the peak horsepower that the intercooler is capable of is going down because I'm now increasing restriction with it. So it's a big time juggling act. And ideally, you would size it to whatever application or purpose the car has, including its power output and everything else. And that's hard to do for a manufacturer that's trying to make parts for the aftermarket, because they got to satisfy everybody, and it just isn't possible. So, all right, flash finally ended. Key off. Wait for it to reinitialize. I'm pretty sure this is just a countdown timer that they put this % on here just to make you sit here for a while. I don't think anything's actually happening during this time. Maybe at the very beginning, but I'm pretty sure nothing's actually happening. Pretty sure they're just making me count down. This time they're actually resetting, so that's important. They're sending the reset command to the ECU, clear out any check engine lights that happened during the flash as it was going on, and then to clear out any potential learned adaptations in the throttle or otherwise, because you don't want that to happen. So then, after a flash, after an ECU reset or a reflash on a Subaru ECU, you turn the key on and you got to sit. You got to wait for about 5 seconds. If you try and crank on it faster, it's not going to start for a while. It's going to and then finally start. And the reason for that is that the ECU is disabled fuel and spark, and it is actuating the throttle. And you can hear it. If you can put your ear next to the throttle body and you hit reset and you turn the key on after reset, you will hear it go like that. And so it's going all the way open, all the way shut, and then the other direction, there's a spring load on it. And you hear it do that. And it logs those voltages and it verifies that the full range is correct. And it says, okay, 100% is 4 point whatever volts on this sensor and 0.7 volts on this sensor, because there's 2 TPS sensors in the throttle body. And then it goes down to 0 and checks the other side. And then it logs those in the ECU, so the ECU knows that when it wants 100%, it has to go until TPS is 4.7 or vice versa. Okay. So I'm gonna do that. I'm gonna key on, get my gear sweep or my gauge sweep. Now on the older STIs, they have the cruise and set lights that come in, and the cruise and set lights come in. Those are actually also tied to the throttle control, oddly enough. And so when those go out, that's how you know it's done doing the throttle calibration. Now what I like to do is also cycle the throttle 3 times, because what it didn't know is it didn't know what the accelerator pedal was. So what I'm doing now is I'm giving it accelerator pedal reading so it too can see where the accelerator pedal is. Otherwise it's just guesstimating for a while. Here we go. Oh, ECU's on, we don't want that, turn that off. Alright, I said I wanted 17 to 22. Looks like we're right here at 18. That's good news. And it's quiet. I don't hear a bunch of bangs and pops out the exhaust. I like it, and it's smooth. So looks like I got it right so far. Roll this window up for the fan noise. There we go. Oh, so much better. Hey, that's nice, right? That's a good post start. I'm a fan of that. Okay, so I'm going to talk to the ECU here. I'm going to hit L. Control L is the old school commands. They have a new command strategy in here where it uses the F keys more and all that. I assume that's also for Apple guys too. But I tried using it for a while, and it was just so foreign to me because it was so different. I had a hard time with it. I mean, I've been doing this for, what is it, 12 years now? It's been the same keystrokes, and they have new ones, and it's been tough. So, you know, can't teach an old dog new tricks, I guess. I don't know. Let's see. Any other chats going on that I need to see here? Oh, yes, we do. Okay. Does pressing the cruise button do anything other than allow you to set cruise control? Why don't they just allow you to set cruise control directly? What do you mean, Nick? What do you mean set cruise control directly? I'm not sure what you mean by that. I know that the buttons, there's to enable the cruise control, so that if you accidentally bump it, one of these buttons, you don't turn the cruise control on by accident. You know, so yes, I want cruise control to work, and this is the set point I want it at. And then, or I want to slow down, I can hold this down. I want to speed up, I can hold it up. Or I can hit cancel to just disable it without turning the system off. So it memorizes my last setting, right? But, you know, instead of tapping the brakes, I hit cancel, I'm gonna coast down. And then if I want to resume, you just bump it up, it goes back to your old speed setting, and you hold it up to accelerate. So I'm not sure what you mean by set directly. But the enable cruise control, then set the target speed. Think of it as a master arm switch. Right, okay, yeah, that's exactly what I'm saying, yep. Yeah, they don't want you to accidentally enable cruise and then bump this thing when you're not paying attention, and next thing you know, the car's accelerating or, you know, not slowing down. Or like if you enable it and it stays enabled and you bump the resume, you had it set at 75, you're doing 30, and you're like, you know, doing something, you reach for something, you bump the resume, and all of a sudden the car's accelerating to 70 miles an hour. There's a liability associated with that, so I don't think they'd want that liability. So they want you to intentionally say, I want cruise control, and then, you know, you're setting it. Now, obviously, I'm not an engineer. Did anything else prevent you from accidentally enabling? No, I don't know if anything else that it would do, honestly. On the Fords, you can use the cruise, or maybe it's the Evos, I forget. You can use the cruise button as an input to the ECU, and it's not in there natively. It's just a trigger for Cobb logic to enable other maps and that kind of stuff. All right, Carter. I know this is off topic, but do you prefer external waste to atmosphere or recirculating downstream? Currently recirculated down by the rear diff. Okay, so you have the setup that I prefer the most. I like to have the external wastegate dump tube be as long as possible. I want, if you think about it, this is the way I think about it. Okay, so when the exhaust leaves the engine, right, it's the hottest it's going to be. It is the most expanded it's going to be, right? It's the most voluminous it's going to be. The mass is there, but the volume is there. As it travels down the pipe, it cools down, and the volume goes down. The mass is the same, right? But it's getting cooler, so the volume goes down. So I don't want that wastegate to dump back in the downpipe when it's all really hot, because now when I have a 3-inch exhaust, an 1.5-inch exhaust, I have a lot of extra cross section in there and lower back pressure. I can let that travel down the car, the air's blowing under it, it's cooling it off, and then reintroduce the bypassed exhaust back in before the muffler if you're worried about the noise, and then that way you know that you have you've maximized the amount of available exhaust cross section for the amount of volume that's coming through it. Otherwise, atmosphere. But my own car, they're all recirculated. They're recirculated in the downpipe, which is a little shorter than I like to do, but that's just what it is right now. On the previous car I had, it went all the way back to the rear diff, and then it was not recirculated, it was turned down. And let me tell you, the short screw pipes, they sound like shit. But a long one that goes the length of the car, it changes the note of the external wastegate completely, and it sounds amazing. So if yours is recirculated in by the diff, if you just cut that sucker off, I think you'll be amazed at how good that sounds. You got to block the other side though, because the exhaust is going to be exhaust leak there. But it sounds really damn good turned down by the rear diff. That's something I like. Do you recommend running flex fuel? Oh yeah, especially on an FA, man. Yeah, on an FA, ethanol all day long. And even just small concentrations, 30%, that's a perfect blend. You can get like 20 horse out of it and it's still knock less and be safer than it is on pump gas. This engine is just such a shit engine. I'm so disappointed in it. I was talking yesterday how I was so excited about it when I first saw it, and I ran the first log on one. I was like, oh, I can't wait for this FA to come out and be able to tune everything. And then I got my hands on it, like, wow, this is really a disappointment. But it's because they have such high compression and they have put such small ports on it. Like the BRZ version is awesome. It's also high compression because it's NA, but it's got big ports and it was made to maximize power and utilize the airflow that's there naturally aspirated. With the WRX, they're like, well, we got a turbo, so if we make the ports really small, make the turbo really fast, and we get good fuel economy and, you know, whatever. and it totally just destroyed the characteristics of the engine. The BRZ with the turbo is so much better than the FA. Like, it's not even a comparison, really, honestly. It's so much better. And so this engine needs octane like I've never seen. I almost think that this engine should never have been released to the public in this compression ratio, because it is just so finicky, and it's always just on the verge of bending a rod. That's how I feel about it. But with some octane, this engine kicks ass. It's a lot of fun. I remember on the stock turbo, we ran a 12 something at Touring Concepts when I was tuning. So the Cobb Suite first came out in 2014 or 15. When I was at Turning Concepts, we were tuning the Turning Concepts WRX. We had our TGV deletes on it. First ones to market with them, and we were doing 12 somethings with ethanol in it on the stock turbo. I think it was like mid 12s or low 12s. It was good though, and it was really it was a totally different car with some octane. And I pushed the rev limit up like Cobb had done, and we ended up bending 2 rods in the engine. And so we fixed the engine, and I lowered rev limit back down again, and haven't had a problem. I haven't had a car bend a rod. Oh no, that's not true. I had one bend a rod on the Dyno a while back, but it was built by somebody, and it wasn't built in a way that I think was correct, and the boost spiked up 20-something pounds. No, it wasn't even 20-something pounds, like 7 pounds. But it happened just, I don't know, bent a rod. It was weird. That's the only other time I've bent a rod on these things since then. But okay, warm-up is almost complete. The whole thing was, man, I'm butterfingers today. The whole thing was butter smooth. So those values are correct for the cold start. I like them. I think the owner's gonna like them as well. I get this down arrow here as if it's gonna, okay, there we go. Why does open loop fueling exist? Okay, so on the EJ, you can't have closed loop fueling in high load. One reason is the O2 sensor doesn't have a wide enough range to do it. The second is the O2 sensor is in the pressurized side of the exhaust. An O2 sensor that gets pressurized above atmosphere, especially significantly, is nowhere near accurate. The factory O2 sensor pre-turbo will give you an indication of 11-to-1 AFRs when you're actually 13-to-1 AFRs. They're that far off. So unless you have an exhaust pressure sensor and the proper calibration to compensate the wideband O2 sensor reading based on exhaust manifold pressure in relation to atmospheric pressure, you can't do it. You can't. It'll be wrong. It will not be consistent, and you'll just blow the engine out, honestly. So if you move the sensor post-turbo and it had enough range and you enabled full-time closed loop, you could absolutely do it with that. But the problem is that the EJ has a transit time that's predefined in the ECU that we don't have access to, and that transit time, if you move the sensor far back, is thrown off, and then you get oscillations, right? Because the ECU has to know the reading is how close to being accurate, right? There's time from when the exhaust leaves the port, goes through the header, goes through the up pipe, goes to the turbo, goes to the down pipe, goes to wherever your O2 sensor is, right? There's a time there. And in factory form, it's right in the header, and so the time's really short. But you triple that length, and now it's milliseconds later, right? The O2 sensor is going to apply a correction back here to the current AFR, which isn't the same anymore. And so what happens is you'll get oscillations, and they start to hunt around, especially at idle and at cruise. It gets really bad. So yeah, it would do you no good to have it on an EJ without getting into and finding out how to change the loop time, the delay between them, so, or the transit time. All right, so I'm gonna start driving this car a little bit. Tires are a little flat spotted. My man boob's shaking here. Dope, thanks. Oh, okay, yeah, no problem. No problem, man. Let me get them rolling so it doesn't keep shaking my brains out here. I'm still in pull mode. Turn that off. I'm just gonna get everything circulating first. I don't want to beat on a cold car. This car got beat on plenty yesterday. I'm gonna try and do it a favor and tune it good so that it doesn't have to deal with that anymore. It's going down some. It's getting a little better. Hey, thanks, Zach. I appreciate that. Let's see. Okay, so I got the real-time stream pulled up. Your coolant temp now has gone up in the normal band now. All the fluids are getting circulated. I like that. And the tires are getting closer, but they're still catching a bounce every now and then. It's an earthquake for you guys. I'm sorry if the phone's shaking. All right. Eventually that'll settle out. After one pull or two, they'll usually do it. Oil temps 173. I like that. I don't like doing pulls on cars on oil temps below 140. That's always been something that we did in airplanes and endurance racing and everything else. Had to be over 140 before we did any love on it, you know. Learn trim 0.8. Oh, I got a 1 now. I'm a loser. Just kidding. And here it's -2, so that's going to keep bouncing around. You'll see that now it's negative again, so it's going to keep going up and down. So that's pretty much perfect. Now that's not my work. That's Cobb's work. So, well, that's kind of true. I adjust this one table over here. So this MAF correction for VE. This table's been adjusted from what it was before, but so the MAF on these cars is two things. It's the MAF table, and that's not the Cobb cal actually. That's my cal for the Cobb intake. So I guess this is my work. And then the corresponding volumetric efficiency table, the TGVs open or closed. And this car will use both because it still has the TGVs. And it reminds me, I gotta double check what I did, if I did that right for these two. Open, closed. Yeah, okay, so you see the closed. I have a lot more overlap programmed in with the TGVs closed than I do with them open. Now that's the exhaust. And intake here, closed. I said overlap, I meant more retard on the exhaust, and this is more retard on the intake than I do open. And so the way they do that is, it's these tables are a joint effort. I know it says TG's open and closed, but they also change, or I'm sorry, from the factory they're also established based on EGR flow as well. The EGR on these cars is pretty effective. And so they don't want to have a ton of overlap in their EGR. What they do is that they actually retard the intake. They retard the intake and the exhaust, and then the EGR effect in as well. So they can reduce pumping losses pretty significantly. One of these cars, after a tune, if you get really aggressive with the cams, what you'll find is in cruise, you'll have very little vacuum in cruise, like right here, hardly any. And that's really good. That's ideal. I mean, you could tune this car to where that said -7, -8 in cruise, and that's fine. The problem is you actually lose efficiency doing that. You want that sucker to be as close to 0 as possible, as if it was a diesel, and you'll get better efficiency that way. You'll have better fuel economy and everything. So the dyno pissed off the car. That always happens on these things. All right, I'm gonna do a poll. I'm gonna double check for any questions first. Any opinions on ported EJ heads? And I feel that would lose a lot of velocity. It does, absolutely. So anytime you port EJ head, anytime you port any head, chances are really, really, really good that you're gonna induce more lag. Plain and simple, you'll get lag. So if you port the head, you're gonna have less response. But it's a turbo car and an engine, so there's always compromise. Do you want more top end horsepower, or do you want faster response? Well, if you port the head, you're choosing the top end horsepower over the response and the spool time. And in some cases that's absolutely needed, and in some cases it's not. In some cases, what I prefer is to put a big cam on a very, very lightly ported head with just the bowl done, basically, to improve the flow right around the valve, and not even go bigger valves, just right around the bowl, and the valve. Maybe open the valve seat up a little bit because there's a lot of meat in there. You can open the seat up a little bit and improve flow through the area, and that's it. Don't do anything else, and you can make a lot of freaking power on a stock port with a big cam. And these cars have ABCS, so if you maintain the ABCS, you'll still have perfect idle. You'll still have great cruising stuff. You'll have good low end torque. You'll have good high end torque, which is also called horsepower, right? So, boy, my fucking bald spot looks huge, right? Gotta love selfie cams. All right. Let's see. All right, we're gonna do pull. I'm gonna leave on the settings as yesterday. No, I'm not. I'm gonna go down to back to the 150 first. So yesterday, if you're here for the test, you saw I did it at 160, 150, and 130. Those are the ramp rates. I'm gonna do the first pull at the 150. So I'm trying to determine. I want to see if my tune's close before I start, putting the big load on it. All right. So we do the pulls in 4th gear. Some people say it's because it's 1-to-1 ratio. Some people say, fuck that. If the dyno's calibrated correctly, if the dyno knows how to read horsepower, it doesn't matter what gear it's in. You do in the 6th gear if you want. It doesn't matter. The issue with doing different gears is not the dyno itself, it's the torque. Gear reduction multiplies torque, which means if I do it in 1st gear, these straps better be freaking strong, because this car's got so much torque, it's going to try and climb out of the dyno aggressively. If I do it in 6th gear, I could probably do it without straps, because there's so little torque going to the wheels that it's probably going to sit on the dyno just fine. I do 4th because it's a good balance between the low and the high, and I get a good range. I can load this car significantly down low, checking turbo boost response, but then I also have enough load up top that the car is strained appropriately. So I do most of the stuff in 4th gear, and then I alter the ramp rates and the speed at which I start the pull throughout the tune to test. I can simulate other gears while still being in 4th gear. Take that ramp rate, make it 210, and it'll just blow through 4th gear really fast. But the hit ramp rate, put it at 110, it'll be like 6th gear up a hill. So I can do that with the dyno and never have to leave 4th gear. Also, 4th gear is relatively strong. The gear sizes are close to the same. It's close to 1-to-1. So that means the gear sizes are close to being the same size from one to the other. So it's not like one is a pinion and one's a ring and one's got a lot more load or it's spinning a lot faster than the other one. So the transmission is fairly balanced in its load to the gears. So that's the other reason. All right, here goes. Starting my log. All right, I hit 20 pounds. I think my target was 19. So I'm gonna double check that and see how much I need to adjust that. My target was 18. Okay, so I overshot my target a little bit. So I'm gonna wanna tweak that a little bit. Let's look at the dyno graph. It looks like I already made a big difference from the other tune on just my base tune. So that's the previous tunes, and that's my first pull. Went from 238-ish average to 270 in one pull. I can't bitch about that. That's a pretty good gain. Yeah, that's acceptable. I got a little bit of a wave here, and so I'm gonna look at the tune in this area. Usually on this dyno, these cars on pump gas will do around between 270 and 280. They don't tend to do too much more than that. That's just what they make on this dyno. This dyno, we call it the Dream Crusher. but it's also mechanical truth serum. So when someone claims that their car has 600 horsepower, I'm like, no, it doesn't. No, not really. Why don't you come put it on the dyno? We'll test it. That's what I was thinking. Big port 207 heads. I was gonna have chamber mash to fit 207. Yeah, dude, I would do that. Are you gonna use the AVCS? If you're not gonna use AVCS, you're just wasting your time. Use that AVCS, 100%. There's no real situation other than maybe drag racing where you don't have huge advantage with AVCS. So if you have 207 heads that have AVCS, then use them. Now if you're talking an older V6 that doesn't have AVCS, well then that's just what it is. But if you have AVCS available, use it, man. There is no substitute. There's no other option in any engine that gives you the ability to have more low-end torque, better idle control, faster turbo spool, and more top-end horsepower, right? Like AVCS has almost no downsides, like other than some complexity, additional complexity. That has like no performance downsides. Some guys go, oh well, I got my cams are too big. Like, well, your cams don't need to be that big. You can move the cam centerline around, or you get huge cams, and if you set the centerline on them correctly, you can when they're machined, you can still utilize some AVCS and get benefits from it. And when the cam's gigantic anyways, if the ramp rate's fast enough, 10 degrees of overlap with a huge ramp rate is equivalent to 20 degrees of overlap with a slow ramp rate. So you don't need to have 4 degrees advanced anymore with a huge cam. You get 10 degrees and you'll see significant gains out of it. My cam that I designed has probably the fastest ramp rate of any cam I've seen on the market for Subaru. I got away with that because I did the direct to lobe oiling, and yeah, right. I did the direct to lobe oiling. I did the lobe treatment, and because I have the extra stability and higher oil load at the lobe, I got away with a higher ramp rate. So it's faster than GSC S anythings. It's faster than almost any of the Kelford offerings. It's faster than BC by far. Those are kind of lazy cams, but the my cams had the best ramp rate of all of them. So I can do that, and because the way I cut the centerline on them, I still have 35 degrees of AVCS available. I don't like it when the techs drive fast in the parking lot. It pisses me off. I just saw a tech drive too fast in the parking lot, so I'm going to say something about that. Anyways, I got distracted when I saw that just now. All right. So I'm going to look at the log. Let's do that. So at the beginning of the poll, is this my log from just now? 2103, 26, 13. Let me double check that. Oh yeah, that's my poll. Okay, so I had a feedback knock event at the beginning of the poll. Let's see here. As I first loaded it, right there. So it popped in, it faded away, and popped a second one. Oh, that's interesting. I didn't see that. I think that's when I was moving the camera. Timing is at 1 degree and 0 degrees. That's not a lot of timing. And so as such, you wouldn't anticipate it knocking, especially only at 13 pounds of boost. Granted, it is 2300 RPM. The air-fuel ratio, we'll see here, is a little high, and that's probably why. You'll see here, I got high 12s, mid 12s in here. If I'm running that kind of boost down low, I should have a little higher. And you see the closed loop correction is trying to bring it back down some. So that is interesting. So I'm going to look. Oh no, so my target is 12.3. So I got to double check my closed loop map and see if that's something I goofed up, or if there's a compensation that's enabled at that point in time. But then once that cleared, unfortunately these things count down slowly over time. Look, I count down forever. There it goes. And then it was good. Still no time on this motor though. So that's surprising really, with only 5 degrees of timing at 5,500, that it made as much power as it did. So that's good news. All right, so I got a little bit of work to do. Cams are pretty balanced right there. All right. So now this is full-time closed loop, like I said before. So we're gonna go to the closed loop fueling map here and look, and sure enough, right there at 2,400, it's still 12.3, and then it dips down. So I can do one of two things. I can be like, oh, I should just never put the car there and during the tune, but that would make sense, right? Because if I can hit it on the dyno, the customer can hit it on the road. So we're gonna add some fuel to that target, because we want to just rich it up just a little bit, especially at the low load, or the high load, low RPM. And I'm just going to hit H to interpolate and smooth that a little bit into this map here and see how it looks. And then it looks like I'll probably have to add some more because that looks goofy as shit. And, you know, that means the ECU's got these weird targets as it passes through cells. VE maps, so that's one thing that people misunderstand. VE maps are going to have jagged ridges and that kind of stuff, because that's just the way reversion works and intake manifolds. It's the way tuning works. That does exist. But having a target that jumps really high from one cell to the next, that's not good, especially if it goes down then up then down. That however doesn't make sense. You don't have a target that does that unless for some reason the VE is so violently different in that cell that you need to change a target to compensate for a problem. But having the ECU trying to hit a target and then go, oh wait, over here again, like, it just doesn't work. You know, hitting a moving target is hard to do. So targets should be relatively smooth, but VE maps don't have to be, because engines aren't technically that smooth. So we're gonna do this. I'm just gonna do this a little bit, and let's see, there's a spot right there. Where'd he go? I see it in the map right here. 12.5, 11, 12.5. So we don't want that. That could be considered a hole. And then the ECU is going to go, oh, I need to add fuel. Oh, wait, I need to pull fuel. And that doesn't make sense. We want to have it a little smoother than that. Okay. So that should help the fueling up there. And I'm going to pull some timing out of this, because this thing overall probably had about a degree too much. I'm just going to start at the, actually, I'm going to go to the log. I'm going to see what the load was. That's not the log. That's Injet Dynamics scaling stuff. So 2.3. So we're pretty much on the right side of the timing map on this case anyway. So that's where I was about to adjust anyways. Oh, we're not up here, right there. So we're in the upper right corner of the timing map. And you see I got -3 here, and then 1.5 there, 1.5 there. I should probably have that tapering, right? That 2 1/2s next to each other doesn't make much sense. If I'm adding that much more load, timing should go down a little bit appropriately. So like those two should be a relatively even jump, because the change in load, well, this one's a big jump, but those two are, there's still a jump, same as that one there. So it would make more sense if it was half degree, half degree, half degree like that. So that, but that wasn't really where we're at. We were over here. You see I got -5 at 16, but at 24 I got -0.5. So it might want just a little less timing right here in this corner. That's where it wasn't very happy. But what I'm going to do is I'm going to go blanket. I'm going to blanket this whole area with just 1 degree less, starting at 2,000. Because you see there's a big jump right there anyways. And I'm going to pull it all the way to 52. I'm going to drop 1 degree out of it. Right there. This is early in the tune anyways, so starting with lower timing is probably better. This was a fully tuned map that I started with a time map, so that was an error on my part. I should have pulled some timing out of it anyways, because every car is a little different, and you want to start in a conservative area, make sure the boost control is right, the fuel's right, before you even start adding that much timing to it. So I should have started with less timing in the first place, but I screwed up. You hear me? I said that publicly. I screwed up. I was paying too much attention to the stream and not enough to the initial startup. Dum dum dum. Dominic said he was wrong. Mark the day. Yeah, right. Happens all the time. Yeah, I should be wearing a beanie. That's my problem. I'm wearing the wrong one. All right, back. Oh, lots of stuff. We're gonna link G4X for 04 STI. You've already merged it. That's awesome. Hold on a second. Okay, so you're going to do a few things on that though. The 207 uses a mag reluctor cam sensor. The STI uses Hall effect sensors. The link won't care which one you feed it as long as you tell it what it is, but you're going to have to verify that the signal is going to the right pin. You won't need a ground side of it. So with a mag sensor, you have cam plus or minus and crank plus or minus. So the link will read whatever. You just got to tell it. So make sure that when you hook the G4X in there, you tell it that your cam sensor is mag, which means you're gonna need a plus and a minus on that one. So you're gonna need to feed that in there correctly. Unless you machine the 207 head for a Hall effect sensor and feed it with the factory STI wiring. Unless you're talking about JDM STI wiring, not USDM wiring, in which case it's already got mag reluctor anyways, and I'm just, you know, wasting your time. But yeah, so if it's a JDM or European, if it's non-SDM, non-USDM market STI, then you're in great shape. That's gonna be awesome. And the G4X is a great system. I love using it. It's a lot of fun. I have it in my own car right now, actually. I pulled out the Adaptronic and I went with the G4X Fury. I don't totally regret it, but there are some features that the Adaptronic has that I miss already. But there are some things that the Link has that the Adaptronic didn't, that I was missing when I had the Adaptronic. So, you know, pick one over the other, I guess. I do wish I went with the Thunder instead of the Fury for mine, because my goal was to put a 6-cylinder in it anyways, and I'm a little low on inputs and outputs right now, and so that's kind of a bummer. Anyways, all right, so I made those changes. Boost control, I want to do boost control too, right? Remember I said it was a little high on the boost, even though the power was really good. So open that log up. We're going to see where we are for wastegate duty cycle and see how hard the ECU was trying to hit those targets. So started at 41 and dipped all the way down into the 30s. So it was pretty aggressively reducing duty cycle to try and get the boost. It's actually down to the 20s now. 27, 28. Now I'm back up. But you see right here the boost error, right? I guess positive number the whole time. Here's around target. Here's a 0 and a low. Here we go. So 18, that's my target, was 18, like I said. $16, 17. Where'd my 20 spike come in? I saw a 20 somewhere, right? Right here, okay. So we see here the negative number trying to lower boost by 3 pounds. And we can see the duty cycle here is dropping as it's making an attempt to bring the boost down closer to target. So it looks like in order to hit my target in this range, I'm going to need to be around 27% instead of 33%. So this range was 2,800 RPM. Clearly it's going to be full throttle, so we're going to go, let's see, check the boost target. Boost target map, looks like that. So one thing I do is I bring the turbo in a little slower on these than some people do. I do that because I'm trying to save the heat soak on the intercooler. But I got the Cobb one in here now, so I might actually bump this spot up a smidge. But I'm also trying to be careful. Have you guys heard of LSPI? Low speed pre-ignition. LSPI is a serious issue that plagues direct injected cars. There's a ton of speculation on it, and they're starting to figure out what it really is, so it's causing it. Right now, it seems like it's an issue with calcium in the oil, I think is what they're currently saying. They're trying to keep calcium low in the oil. They find that the calcium in the oil is causing a significant reduction in octane and causing detonation. But not just detonation, pre-ignition. So the difference, pre-ignition is before the cylinder or the spark plug fires, whereas detonation occurs long after the spark plug fires. So knock happens about 20 degrees after top dead center, near peak torque, or peak cylinder pressure, as I explained earlier. And so in this case, LSPI is happening as the piston is traveling up in the compression stroke. And the way the graphics that they show displayed is that the rings are wiping oil off the cylinder walls as the fuel's being injected, and a reaction is happening, and it's causing ignition of the air fuel mixture. Like I said, it's still largely speculated upon, but they've been testing different oils and finding that things like calcium and boron and zinc and phosphor all have an effect on LSPI, and they're finding that calcium so far, at least to the best of my knowledge and the latest papers that I've read, is that calcium is the biggest effect in that. And so the Dexos grade oils, which are made for direct-injected cars, have reduced levels of calcium and other additives that they've found cause LSPI. Now, LSPI happens at high load. So if I target a bunch of boost at a low piston speed, I'm adding high load at low speed. That's the L in LSPI, right? Low speed LS. I am increasing the chance that LSPI occurs. So I don't want to go too crazy down low, is basically what I'm saying. I don't want to throw a bunch of boost at it when it's going slow, when the cars are making plenty of torque, and I don't need to heat soak the intercooler and increase chance that it blows itself to bits. So, and then if I get everything it has at low RPM, I'm not going to have a nice pretty power curve that, you know, goes like this. It's going to be a flat power curve, and the car's going to feel funny when you're driving it. Okay. So now I'm back to duty cycle. All right, let's see here. Move this out of my way. All right, duty cycles. Now, the highs, look at that. I have these in the 50s on this one. And this thing was running itself in the 30s and 20s. So these are just too high. And it's pretty much global. It's almost globally too high. Now you see a huge reduction in duty cycle as you approach red line. This is because this engine is so sensitive to back pressure. Actually, red line's up here, right? Up here. That you want to remove back pressure as best you can. And reducing the wastegate duty cycle is a fast way of reducing back pressure on the engine. So I'm going to select this whole group right here, all the way up actually, and I'm just going to go across. I'm going to pull a percentage out because right now it's just too much. And that still might be too much. I'm going to do a little more. So I pulled about 30% out of it. Get it back down in the 30s. Now, I don't want to take this down too far. Today is a cold day. So if I set this to the maximum to what it takes today to make the boost that, that we're having, it won't make the boost on a warm day. Right? So I got to leave it room here and then utilize the intake air temp compensations to pull duty cycle out on cold days and add it on warm days. But this has to be high enough that it can actually hit boost on a warm day. Otherwise, I'm just neutering the car in the summer, really. Or get the heads covered, converted to USDM sensors. Oh, okay. Sure. So you're here in the US. Yeah, that should be fun. So you're going to use the USDM cams as well then? So like an aftermarket cam for now, are you doing this on a 2.5 liter or on 2 liter? I might have missed that. Oh, I think you said chamber mash, right? Yeah, chamber mashed. Okay. Yeah, do all right. That should be a good time. Did you already order your cams for me? All right, so I got reduced duty cycle. I've got more fuel. I've got less timing. Reduced wastegate duty cycle, not just duty cycle. Yeah, duty cycle's less. Wastegate duty cycle's been reduced. And so we're doing the pull. See how it does. See if I still have that little bump in the mid-range. And see how well it still carries power towards redline. Obviously, as you saw, there's a 40+ horsepower gain for peak, and almost 100 horsepower gain at 6,500 RPM versus the other map. So, yeah, I don't know, man. E-tunes suck. I don't like E-tunes at all. I often rant about how bad E-tunes are. I'll tell you after this pull. We'll talk about it. It felt nice, except the boost went higher. F-U-F-A. Let's see here. So I lost 10 total horsepower to the wheels on that pull up top, but it was smoother through the top end, which makes sense, right? I pulled the whole timing across the board there, pulled the degree across the board, so that's expected. I'm gonna verify the log and make sure it's pretty close. But that boost was at 23 pounds, even though I reduced it down almost 30% less than it had before. Some of that could be because I reduced the timing enough that there was a lot more heat in the exhaust, and that extra exhaust heat created a more responsive turbo. And some of that could be because it's just a fucking FA and it hates my life. And then the rest of it could be the amount of heat in the header after this pull was more than the first one, because the first one was done on a cold header, this one's done on a much warmer header. So the exhaust gas is more voluminous, it's more expanded, and therefore the duty cycle has to be even lower to get that gate to open even more to control boost pressure. All right, clear this graph because there's way too much stuff going on here. So you'll see the graph here, if you can see it from back there, I don't know. You see there at 3,700-ish. There's a lot more torque right there. So I picked up a bunch of low-end torque because the boost went up higher. And then I lost a little bit up top. It's carrying power pretty well to redline. Can't really complain about that too much. It's doing pretty well. You know what? That could be a lie. Let's do a little rescale on this dynograph, and let me show you how scaling the dynograph a certain way can portray a totally different situation. And we see this all the time. You see stuff online where someone posts a dynograph like, wow, that looks really good in appearance. But then if you actually go down and look at the numbers, you're like, what the fuck is going on here? That graph's got a little waver to it, right? Looks like it's carrying power pretty well towards redline. But it's squished, right? So those differences aren't nearly as obvious. So I'm gonna change the scaling, not change anything else. And we're gonna see how that graph still looks. Wrong button. All right. So we're gonna go down to 600 peak or 300 peak. Not the same beautiful graph anymore. Looks kind of funny. Now, for an FA, it's still doing pretty good carrying power towards redline. For an FA, that's still pretty good, but with some more working time, you could probably get it about here-ish, and kind of flatten this out a little bit. But that's a big spike. I don't need that. I don't really even want that. And yeah, so it's not the same pretty picture it was with the scaling all reduced. But you'll see that a lot. You will see a lot of dynographs where they've altered the scaling to deceive the public or even the customer when they see that, oh, look how smooth this is. This is so beautiful, yeah. And if filtering is on set like 100 and it's knocking out every wave in the whole graph, yeah, that kind of stuff happens. Now, I don't have any filtering options on this dyno that I know of. Yeah, I don't know any filtering options on this dyno. And sometimes I wish there was a little more filtering. I guess the air temp sensor picks up noise, which it'll do. Sometimes I gotta ground the car, the dyno, and the air temp will do this, and that noise gets in the whole system, and then everything just starts to read wiggly. So, all right, this one's gonna take a little more time and concentration for me, so I'm gonna set the phone down towards just here so I can use both hands on the thing. Feel free to ask questions. I'll still talk them out, but I gotta use both hands to do this, otherwise it's going to take me hours longer than it should. So if you got any questions to ask, I'm just gonna plug away at the laptop here for a couple minutes. See what we got. I'm gonna check for. I'm gonna plot this in a spreadsheet. I'm gonna look at my parameters over time. We'll see if there's any weird waves that I missed in my cam timing that may that may lead to that weird power curve. I'm going to check ignition timing, boost, and all that, and see if anything coincides with the bumps that I got out there. I know that boost pressure is going to be one of them because I saw 23, but is it going to be the only one? You know, or what? You're asking us how audio equipment. Oh, I bet, dude. Yeah, Travis Cook down there. He's a good tuner. He's got a dyno in his own house now. 97 mm bore. Yeah, I got no deals on cams, man. I'm already losing $100 per set that I sell. I sell them at $13.50. I'm still losing $200 a set. So G35 900 or EFR 8374. Those are both good turbos. Honestly, the new G series is so fucking good. Like, I might not be using EFRs anymore. I did a back-to-back testing. That's a lie. It wasn't back-to-back. It was a comparison between two different cars, but one had the EFR, one had the G30 on it. Actually, it had the G25 on it. I had this. What did he have? I don't recall if he had the 8374 or the 7670. I think it was 7670, and the G25 660, and the power curves were almost identical. The EFR did come on a tiny bit sooner, like 100 or 200 RPM, but the power output and everything else was just laid on top of each other. And 200 RPM for a difference in thousands of dollars for the turbo kit and complexities and everything else, I'd take an equal length header and a single scroll G30 or G25 any day, you know. In your situation, yeah, the G35 900 is a big turbo. That's a really big turbo. That thing's moving some air. So if you're ready to make that kind of horsepower, then I would go that route. But the G30 770, whatever the heck it is called, is freaking amazing too. You can get a lot of horsepower on that. My Forester at Audible LSPI? I would be surprised, because Audible LSPI almost immediately results in parts breaking. So did you break pistons? Because that would be, yeah. Yes, Travis says Dyno. Yeah, he does Cobb. He's a Cobb tuner. Soulless Performance was the shop. Travis Cook. So you're seeing the raw data probably has going on. You know, the numbers on this screen here on a log, they tell you a lot, but they're not the whole story by any means. And that's one reason why I don't like e-tuning. When I'm in the car and I'm tuning it, I'm listening to it, I'm feeling it, I'm even smelling it. You know, I get to look under the hood, observe the installation, see how everything's put together, and you know, there's decades of experience there that you can't use to look at numbers on a screen, you know, with those sensations. I can hear pops and misfires and slight burps, you know, that kind of stuff. I can hear, you know, a shudder or something that the person taking logs probably wouldn't hear, and they won't show up in the log. So I don't like e-tunes because I also can't back up the customer. You know, a lot of the e-tune customers are getting an e-tune because either they can't afford a dyno tune, which it's hard to support that, but they put their own cars together, and they're not going to have the decades of experience putting these cars together. And so I can't back them up before we do our first pull, you know. And so if they did something wrong and the car blows up, well, like, what the fuck can I do for you, right? That I was not afforded the opportunity to help, you know, find an issue before it became something expensive. And I just don't like that. You know, I don't like the inability to provide you the best tune, because all I'm looking at is numbers on the screen. You know, the virtual dynos are fucking garbage, man. Like, people swear by those things. They're not accurate. That's stupid. I just don't, you know, you can't get steady state loading on the road. You can't, just, it's so limited. And then it takes so much time, even as an e-tuner, to tune, you know, via logs, trying to explain to the guy how to take the logs. Hey man, don't send me 20 minutes of data. Like, my computer only has so much RAM. Like, just don't do that. You know, like, trying to go through all that shit just sucks. I want to have the car. I want to look under the hood. I want to make sure things are done right. I want to take out the lying factor. I've had guys lying about the mods because they know, well, he doesn't like this kind of injector, so I'm going to tell him it's a different injector. Like, don't fucking do that, right? And then, like, the E2 never goes right, and then I'm getting slammed on the board because I didn't tune the guy's car right, you know, and it's like, dude, you fucking lied to me. So there's all kinds of reasons. Just don't like doing E-tunes. Alright, so it did richen up where it was supposed to, where I added the extra fuel at that 2.3 load. It richened up. That's good. It pulled clean through the rest of the power, through the rest of the pole. There was no timing reductions, so that's good. The boost was a lot lower up top. Since I did that blanket reduction in duty cycle, the boost dropped quite a bit up top, which is probably why I lost that, all that horsepower. But what's with that spike? I'm trying to find that spike. Oh, here we go. 22 pounds. Yeah, my duty cycle is way less than it was before. That is interesting. That was at 3,300. All right, so I'm gonna have it be a little more aggressive on the turbodynamics. I'm gonna force this thing to really try and maintain boost. The turbodynamics is really, really dumbed down from the factory on these things. And in Cobb too, they didn't really do a whole lot to really push them hard into to try and hit the desired boost. And part of that is because the factory boost control solenoid is really bad. Plain and simple, it sucks. And it doesn't flow enough air to provide good response times. And then it has two restrictor pills in it that impede the ability of the system to respond to changes in pressure. And, well, like I said, that sucks. We don't want that. Okay, so I've got the proportional relatively high. So boost control, let's talk about boost control a little bit. I've talked about this in multiple videos, but we'll do it again today. Boost control is typically a PID control. On Subaru, it's PI, there's no D. So it's a PI control, the proportional and integral. Proportional is what is the error at this time? Immediately, what is the difference between what I want and what I got? That's proportional. And so I'll show you. So right here, proportional control. If the error is 3, it's going to alter the duty cycle by 4. If the error is -4, it's alter by -5, right? So, and then everywhere in between here. Okay, this is how aggressive is it going to try and adjust duty cycle based on the error. Now the problem with that is that's only going to go so far because that's not cumulative. It's only at this second, how far off am I? And so that comes right off the map, and that's all there is to it. That's what you get. So it doesn't do a lot for you, only that if you have it too aggressive, you can get some boost fluctuations. The next one's integral. Integral is the one that's cumulative. So that's the one that adds up over time. And if you look at integral is technically the area under a curve. And so That's saying if I have what I want and what I got, or vice versa, what I got, and I plot that over time, okay, how much is in here, right? And that is what's happening. So as it's wrong over time, it's going to keep adding up, and so you're adding up duty cycle in here. That's that area under the curve. That's the best way I can think of describing it to you, but it is based on the error duration. How far has it been off and for how long? And so it will pull it and say, okay, I'm off this much. I'm going to add some to it. How far am I off now? Okay, I'm going to add some to it. So it's going to keep adding up. And that's where that area comes in. So right now, I'm going to leave the proportional where it's at because I like where it's at. I'm going to increase the integral some, and I'm going to make it count down faster, pull away duty cycle faster to lower the boost quicker. Now this one is a base map. I have to reflash this one for it to come into effect. So I'm going to do that. I'm going to save it. But I also want to adjust the top end wastegate duty cycle because it did drop the boost so darn far. And I want it back. Oops, too much. Oh, wrong button. All right. Okay, now we'll flash the car again. Add a little more boost up near the top ends. I pulled the smidge out down low in that area where I just added it. Decided I didn't want it there. Instead, I want that big bump in the graph. So I pulled it back out. You know, a large portion of tuning a car is about providing an experience for the customer. And a lot of customers want something a little bit different. You know, some want the initial rush of a turbo. I had one guy say the other day that he wished it was more laggy. I was like, what? He wanted to be laggier because he wanted the anticipation. He said he wanted to be more build-up. So he wanted to be dead and then suddenly hit and be like, wow! You know, that's what he wanted for his tune. And you know, my response inside my head is, you're fucking crazy. But I mean, if that's what the guy wants, what the guy wants, right? And so, massive layers of shirts here, give me fucking jowls. But that's what the guy wants, what the guy wants. And so I'm like, all right, well, I mean, we can do that, but like, the car's slower, you know? And then there's the other side of that. Some guys want every bit of torque and power they can have the entire time. And we can do that too. And technically that can be faster, especially for like a single pull off the light. But then there are downsides of that. You heat soak everything. The intercooler gets a bunch of heat just dumped into it really fast. And that impedes top end horsepower. If the intercooler is small enough, what'll happen is you get a bunch of torque down low and you'll dump a bunch of heat in the intercooler, and then up top you're going to lose power. So there's definitely a balance in there to be had for the best running and most consistently running car. Yes, I can make a car accelerate a little faster from 1,000 to 4,000, but then it's going to accelerate not as good from 4 to 7 because the intercooler is heat soaked. So I try and get a car, or try and tune a car so that you get that balance. Unless the guy has asked for something in particular, my goal is to get as much top end as I can, because, you know, horsepower people want. I want that graph to taper upwards. I want the torque to be as flat as possible. I want it to look like a big NA engine for the most part, you know, with some exceptions. It's still a small engine and it still has a turbo, so there's going to be, you know, some area where the torque is high and then falls off. It's just going to happen. But my goal overall is to get a horsepower curve that is not a flat line. You know, it's 500. You know, like that's improperly balanced engine. I want that curve to come up. You know, like when you shift, right? There's that feeling when you're in the car. That horsepower is climbing the whole time. You feel it pulling on you. That's the experience that a lot of people want and they want to feel. And so I try and tune it like that. But sometimes I do get some odd requests. And yeah, he didn't like that there wasn't enough lag, and he didn't like that the launch control on the car that I did, or the launch control was so instant. He wanted the launch control to have more build up too. He wanted the turbo to sit there and spool for a while before the launch control started to pull timing and fuel and everything. And I was like, all right, dude, well, I appreciate your input, but, you know, I want the launch control to fucking work. Not just to provide you with some sort of anticipation show, you know. This isn't softcore porn, right? So, but some people want weird stuff. Let me know before the tune, so I can laugh at you till you go somewhere else, or, you know, accommodate. Let's one or the other. Leave the window cracks. Maybe you can hear the dyno noises and stuff. All right, so I didn't adjust the wastegate duty cycle at all. I only adjusted the compensations for it. So the question is it still going to overboost? It might. But I'm curious how far and how the system responds to the changes I made. So, let's find out. Yeah, I went too far on one of those. Yeah, that's funny. Well, I got part of the graph smoother. Part of it is smoother and part of it is not. So one of the areas I worked on made a big difference. It's a lot better. Another area, not so much. Not so much. Okay, so where's that spike at? Is it still spiked? 22. All right there. So bright side, no knock during the pull. Nice knock free, clean pull. Top end power is very smooth. The graph is smooth up top. I'll show you in a second when I can get closer to it, but the spike still happens, and then it overcorrected. So it has me thinking, maybe I'm wrong. Maybe this car has a stock EBCS on it with just the pill delete. I thought I was told it had aftermarket EBCS on it, but it might not. So I'm going to check that right now. I know what the guys tell me, and sometimes it's not always the case. This car's been in and out of here a few times, so I could have heard wrong, or they could have told me wrong. But the fact that it still spiked as much as it did makes you think that potentially the booster solenoid is factory. They do that really bad. They do. So I'm going to take a peek. Let's find out. I'll get the lower trace off. I was wrong again. It is the stock solenoid. Mother bitch. All right. So what does that mean? Well, what that means is that I'm gonna have a hell of a time keeping you from doing that. That's just the way those damn things are. So I can make a big change. The seatbelt's stuck. There we go. To the duty cycle down low in an attempt to prevent that spike. So I'm gonna try that, see if that works. Otherwise, the other option is I gotta tune with the spike. I can do some things with the cam timing to minimize the size of that spike, make it more difficult for the turbo to do it. And then otherwise, just pull enough timing that it's safe if it happens. So there's a no knock during the spikes now. It's technically time and safe. Just now it's a matter of getting the boost to be smoother so the power curve, oh, power curve, that's right, that's what I want to say. And then get rid of the last one, or one before last, I mean. Bring up this last graph. Yeah, so you see the top end is looking smoother than before, not as much drop. It's very nice and linear. I can still work a little harder to get this up here. But then I got, yeah, so I got that. Now that means one of two things. That means that theoretically, as long as a portion of this isn't the dyno, because it does happen, if the power comes on really quick and the car moves on the dyno, I'll get a power up and then a power down as the car settles back down again. So as long as none of this is that effect and this is all the engine, in theory, I should be able to take this line and just swing it over like this. And I should be able to make this curve a big continuationized arc. In theory, I should be able to do that. Considering how much timing I pulled in here and how I lowered the boost in this region before, if I wanted to try and ride that spike a little bit, I could do that. Now, I definitely would not want to do that on the stock intercooler because it does heat soak so fast in it. But with the Cobb, I could do that and probably get away with it. The intercooler or the charge temps would probably still stay low enough to not hurt anything. So I'm gonna try and do a little bit of both. I'm gonna try and cut this in half and feed it in through the half a little bit and kind of split the difference. Any questions since then? Oh, a couple, here we go. Holy crap. Also, how the car drives and feels is 100% more important than numbers on the screen. I agree. Omni, definitely. $600. BP for a tune is about $600. Teaching tuning online. I do that. I mean, you're here now, right? So you're getting a bit of that. But I also have a tuning class that I teach. I used to do it a lot. I haven't done it the last couple years, but I used to do it quite frequently. It's not cheap though, because I do go so in depth with the EJs and everything. I'll check him out. Yeah, well, he just closed his shop actually and moved it to his house. He got a new house and had a big shop on it, took his dyno home. And he's doing it by appointment only, and he's kind of selective about it. So he may say, you know what, a stage whatever car is simple enough and, you know, make a few $100 and do it. And he may not. So I can't tell you the answer to that. Nick, no, not at all. Do it. Have fun. If the tune's good and you do a few things, then you should be good to go. Like your tuner's got to not be a fucking idiot. So and unfortunately, a lot of them are. A lot of them think though, well, it didn't knock, so it's good to go. And they just add timing until the heads lift off. I had one guy at a rally event. He's a tuner for another rally car, and he came to, hey man, I want like the third engine in 3 events, and I can't figure out why. And I said, oh, well, what's your setup? Told me a setup, and I said, what's the problem? He goes, well, I keep lifting heads. And I said, oh, okay, well, let's see. Based on your setup and what you're telling me, I said, you probably have 25 degrees of timing at peak torque and about 30 at redline. He was like, that's exactly what I have. And I go, man, that's exactly your problem. Just because it's not knocking, man, you know, it doesn't mean you can keep doing it. And the power may have kept going up on the dyno, but the dyno and the track are not the same, especially in a rally event and all that. You know, like, it's got to be like 6 degrees less than that. You've got 6 degrees too much timing in it. Maybe 8 degrees less. I think I'd probably run 14 to 17 peak on that set that he had. But I knew from my own errors that I have pushed them to 25 in that range because I've watched what happens to the power, and I've watched what happens with all that stuff, and I saw what happens, you know, in the end. So a lot of guys are stuck thinking that if it didn't knock, then it's okay, and they end up letting the turbo do its job, and that's separate the top and bottom half of the motor. You got to keep it in line. So, more of the story, yes, you can absolutely run Dom 1.5 on 85 on the stock block. That's not pushing it at all. If you do an intake air temp sensor relocate, where you put it post intercooler and a cooling mod, you can run way more than that, really. I got a couple nicks in here. Boosting at 18.3 on a stage 1 with turbo inlet. It could be the boost controller because of stock. No. The answer is that is no, definitely not. So do not confuse the things I say about an FA20 with an EJ. They are quite different in a lot of situations, and one of them is the boost controller. The stock boost controller on an EJ is perfectly fine. It works very well, and that is just a factor that the person that tuned it, it's not tuned for what you have on it, plain and simple. Or they didn't do it right. Well, if you're on yeah, I mean, you're on a freaking OTS map, so that's why. Yeah, and that's what will happen. When it's cold, you'll get more boost. That's with any car. That just means that it needs more compensation for low intake air temps. Yeah, Junior and Graham are both great tuners. So 10 versus 8, it's a matter of spool versus power, whichever one you want. You want more top end, you want the 10. You want faster spool, you want the 8. It's as simple as that. You choose what you want. I'm looking at my tune, or look at the map, the log. Boy, I'm all over the place. Look at the log of the last one. I'm gonna look at the turbodynamics boost error. Right now, with the boost error, it gives me an idea of what the car is trying to achieve. And if that error is very large, it's because the actual boost and my target boost are too far from each other. And if they're too far from each other, what you'll get is called integral windup. An integral windup will result in a boost spike. So the question is, I'm blaming the boost controller, but is it my fault? I mean, it could be. So that's what I'm checking right now. Okay, so the answer is no, but it's also almost. So that being said, what I noticed that in the log at the beginning, there's a large section that has a very high boost error. And during that time, the duty cycle, I guess the owner of the car's here. There we go. So the audio just kicked on and connected to somebody's phone. I assume that's the owner. I don't know any other reason why that would happen. But we're jamming out to Nate Dogg and somebody else. And even though you keep turning the volume down, it keeps turning itself back on. It just went up again on its own. These factory hidden units are fucking garbage. Anyways, what I was saying is there's a large period of about 1,000 RPM where there's like a 14 PSI error. And the waste heat cycle is climbing up. Now, if the spike happened right after that, then it is absolutely a case of integral windup, and it's absolutely my fault. In this case, though, the error that's 12 goes down to 1, and stays 1 for a long time, and gets to 0, and during that time, the duty cycle is not climbing, and it's staying pretty steady for a long time, and then all of a sudden the spike occurs afterwards. So it's not my fault in this case, but I do need to do something to make it less prominent. So one trick that you can do to minimize that integral windup is to have your target boost pressure be realistic. A lot of guys make it unrealistic. I see a lot of tunes, open source stuff. They'll show up, noob guys will take the whole right column and just say 22 from top to bottom. And that's not how you do it, right? Your target boost can't be 22 at 1800 RPM if you get a 20G on a 2-liter. Like, that's not even physically possible. And doing that means you're probably going to hit a really, really high boost number when you're not supposed to. So what I like to do is look at the boost curve of the car on the dyno and see what is it at 2,000 RPM, what is it at 2,500, what is it at 3,000, what is it at 3,500 at full throttle, see what I'm getting. And then set that boost target close to that, maybe a tiny bit above that, depending on where it's at, and maybe a tiny bit below, depending on, again, on the car. So if I set it close to that, at least I know I won't suffer from any integral windup, because I'm already getting the most that the turbo is going to offer me. So I'm gonna double check that right now. It looks pretty close to the log, other than that sudden spike up to freaking 20 PSI. That's what I'm gonna do right now. So I need to find RPM, where did it go? There it is. Okay. All right, so I'll show you real quick here. So right here, my manifold pressure, you see here I got 11 pounds at 2,300-ish, right? But that's where the pull starts. So it actually goes up a little more as the car is sitting at 20, held there. It's allowed to spool, all right? So, well, that was weird. I lost phone signal. It just said 0 bars all of a sudden on a big X. It's the 3rd time today though, so I don't know. They're doing some weird shit in this town. I think they're installing 5G antennas like every fucking 100 yards. It's really weird. I've never seen them before, but it's like every 100 yards this antenna they're putting up looks like a 5G antenna. So I don't know. Maybe that's what it is, and they're installing this new shit here in this area. So sorry about that. Yeah, the thing just said disconnected from YouTube. All right, so that one wasn't any better. Well, it was a little better, but it wasn't good enough. So I made a bunch of changes while the phone tried to reconnect. Try it again. Yes. Yes. That was an improvement. That was definitely an improvement. That time I did pretty much exactly what I wanted, and I split the difference. Let's see. How much room do you give in the ECU and corrections? How close do you keep your low target beat cycle? Depends on the ECU, year, make, model, etc. What EBCS it is, and all kinds of stuff. It also depends on how much boost you're getting per percent. If the system's really sensitive, then you can't give it a lot. If the system is really dull, then you can give it tons. Anyways, ignore the green one. I was in the wrong gear. But the blue one is what I just did. So I split the difference like I wanted, and I got back everything else I wanted power-wise. So that looks a lot better. So I'm happy with that. That's a good step in the right direction. Now I'm going to start adding some timing up here again, because I pulled a bunch out up here too. So I'm going to add some timing up here. I'm pretty sure it'll handle just fine, and I think I can get this to be a little flatter through here. But overall, that's the curve I'm looking for, and I'm very happy with that. And I forgot to clear the freaking boost thing. But we'll look at my log. Let's see what we got. Hit 20. Hit 20, but what I did is I just set the target to 20. I said, fuck it. All right, let's set the target at 20. So you'll see in the mid-range there, I gave it 20. But I kept it really low in that low area to keep the wind-up from happening. And really, what I got is a boost curve. Looks a little bit like that, actually, in the end result. And it was very smooth. The whole car pulled very smooth. But unfortunately, that's kind of how extreme you got to go with the factory boost control solenoid on a car with an exhaust. They spike really hard. As you can see, if this had an aftermarket solenoid like a Cobb or Greenspeed, then I'd have it set at probably 30-something% across the board, and it would give me an almost perfect boost curve. And then I just make small changes up and down from there to get it the way I want it. But unfortunately, with the stock one, it's just so inferior. It's just too small, and that's kind of how you have to deal with it. But yeah, I'm happy with that. That is a good change in the right direction. The power is about where it should be. I do want to change a few things on the dyno to change the loading, simulate other gears like I was talking about before, change the ramp rates and all of that. So I'm going to do a ramp rate on the same tune with no changes. See how it comes out. To simulate another gear. I want to do this in different gears, right? I want it to be effective in all the gears. This one is going to simulate third gear instead of fourth. That was a big change. Looks good though, acceptable. Definitely held power quite a bit more up top. So now we're gonna go the other way. I'm gonna put it in fifth essentially. I'm gonna simulate it in a higher gear. I'm gonna go back down to that 130 like I ran before. So this should get nice and pissed off, but you know, that's what we want to check, right? I want to make sure that it's safe when the customer takes it and goes railing on it all the time. Because honestly, that's probably what's going to happen. It actually liked the slow ramp rate. Picked up 20 horsepower with a slower ramp rate. I see that sometimes. I'm a little surprised this time at how much it picked up. Sometimes it'll pick up quite a bit. Sometimes it'll lose some, might get pissed off, might knock a bunch. This one is perfectly clear, no knock at all. It liked the slower ramp rate, plain and simple. Wow. Check this out. Picked up 20 horsepower. Okay, 19, I don't want to exaggerate. 19.5. Or, yeah. From bottom to top. My guess is a little more boost down low with extra load, and they just held it really well up. A little wiggle up top I'd like to see if I can get rid of. But overall, like, that is super respectable. So I'm gonna take a look at the timing in that area. I never did add that timing I was talking about. So from 6 to 65, it probably gained some power up there. Let's see where we're at. 6 to 65. I've got I've got 9 degrees on it essentially. It's pretty good for an FA. They don't like a lot more than that. But again, the Cobb's on here and it's got cool air temps, so I'm gonna try it anyways. I pulled a bunch out there at the beginning of the tune, so I might as well add that back in that zone. Let's see what she does. I'll put a whole half a degree in, that's it. I remember the days of Big Al. I don't know if you guys know what Big Al is from Dyno Flash, bro. He would always talk about everything, and everything had a bro in it. Hey, bro, we're gonna tune your car, bro. What do you think about your car, bro? Hey, that's the time, bro. I have to agree, bro. It's gonna be time. I mean, all the time it was bro. It was great. And he had the best videos ever. And unfortunately, the internet is a cruel fucking place, man. And he did some dumb shit a couple times and just got fucking annihilated online for it. And I think he had a breakdown. Honestly, I think he had a breakdown because all of a sudden he found Jesus and he said screw tuning for a long time, and then he went to law school, became a lawyer, went on Judge Judy and got fucking destroyed by Judge Judy. It was hilarious. So if you've never seen Dyno Flash Big Al when he goes to Judge Judy, because he was what was he doing? He was I think he was an Uber driver, and the person damaged his car pulling the bags out of his car or something like that, and so he sued them. And he represented himself and kept saying how he was a lawyer and shit. I think, is it Judge or People's Court? Maybe it was People's Court. I think it was People's Court. But anyways, he got annihilated on that too. It was pretty funny. I felt bad for the guy because, like, he's one of those guys that you can tell has a huge heart. He's just not always doesn't have the common sense to say that he probably should have. But yeah, those videos were great. Lots of bros. Anyways, the reason I brought him up, I remember watching one of his videos once, probably 2008, and he said he was going to add a 1/4 degree of timing and see how much power it made. And this was on an EJ, and I fucking laughed my ass off because an EJ, Corey was like, what's this, a 1/4 degree? You know, what is this, timing for ants? You know, it'd been like something something like that. And so I said I'm going to add 1/2 degree, but on the FA, 1/2 degree is a lot of fucking timing on these things. So that just made me think of Dyno Flash. Anyways, thanks for following me on a trip down memory lane. All right, the bitch loaded up. Let's do it. Well, it didn't knock at all, and power did go up. Power went up a little bit towards red line, went up to 6,000. There's still a little wiggle in it that I wish wasn't there. So I'm gonna look at some other stuff. I'm gonna look at wastegate duty cycle, see if I see a wiggle in that, and then see where the boost was. But now we're at 299. I have no idea if you guys can see that or not. Please let me know in the chat if you can, so I'll stop doing it if you can't. Oh, there's actually a wiggle in the timing. 2 little wiggles in the timing. There's no learned correction. There's no fine knot correction. I'm sorry, there's no feedback and there's no fine. But it does change about a degree, and then it goes up half, down a degree, up a degree, down half, up a full degree again. So the question is, what the fuck? Like, why did it do that? So I'm gonna look at, see, intake temperature is completely steady in that range. So that's not it. I'm gonna guess calculated load is flickering around. They do that on these things sometimes, yeah. So one thing that these cars do that's really freaking annoying is they don't filter their calculations well enough. Or their inputs. The map sensor is just doing this, catching every pulse of every turbine blade going by kind of stuff. And they don't filter it well enough. And it creates a lot of hassle sometimes, especially if you go speed density on them, then it becomes a freaking nightmare. So the calculated load is bounced around quite a bit in that area, which means the mass airflow is probably bounced around a little bit right there. Yeah, and it is quite a bit. It's going from 255 to 274, back down to 257, up to 260. All right, it's dumb, but that's an FA thing for you. Watch this, look at this. 59, 64, 57, 53, 61, 63, 62, 56, right? This sucks. That sucks. Because that means that your calculated load, which is this, right? Calculated load is based off the mass airflow. It's this times 60 divided by RPM, right? Is that right? Or is it times RPM divided by 60? I always forget. This is mass airflow, so it's grams per second. So you do seconds over minutes, yeah. So anyways, that gives you calculated load, which is grams per cylinder, or grams per revolution, whether you divide in the number of cylinders into that or not. Depends on what engine management system you are using. But yeah, you see that bouncing, 2.4, 2.38, 2.35, 2.30, back up to 2.39, down up to, oh, here's 2.4 again, next to a 3.7. So that range is causing my timing to bounce around. So I can combat that directly by going directly to the timing map and then smoothing in between those load cells a little bit and try and either smooth them out or make them almost the same value. But that kind of sucks because I don't want to be the exact same value, because when load is actually higher, I want less timing. When it's actually lower, I want more timing. But it's not really giving me that choice. So let's see, Cobb adds a lot of features. I'm gonna see if they have a load calc smoothing in here. They've been doing so much stuff lately. Let's see, here's boost smoothing. Now we're talking for boost control. That's there. That helps with the wastegate duty cycle response to help knock down those the reactions to the highs and lows that happen. It helps average out the map reading. But I want something for MAF smoothing. Yes, here it is. They did do it. I thought they did. Okay. So they have what they called MAF Simple, and MAF Simple, what they did is they kind of took out that VE table. The one I showed you before, I told you the mass airflow was based off the mass airflow sensor, and then it was corrected for VE on that VE table. And doing both of those together can sometimes create a tuning experience that takes a long time. And so what they said was, you know what, F this table, let's just make the MAF. But they also had to do it for speed density, because for the speed density calculation, if you have all these other VE calcs, various areas of the table, that screws it up. And the way they do their speed density setup is they take the pressure and the temperature and they do a calculation for mass airflow, and they insert that mass airflow value into the area where the mass airflow sensor would be reporting that. So then that would get hit by a VE table correction and then get hit by the VE for the whole engine again in the speed density tuning. So it would create an issue where you're getting double corrected, and that would kind of screw things up. So they had to get rid of that table. They created a MAF Simple thing. And I know I'm telling you that as if that's 100% factual, but I'm actually assuming that that's why they did it, because that's something that would make sense. And maybe also because you guys are like, hey, you know what, this is too hard to tune all these stupid tables, let's get rid of them. But the idea is that you don't want to have your mass airflow calculation, which goes right into your load and everything else, be corrected for VE twice by two different tables in line. That would make any sense. So, all right, so I'm just going to smooth that out a smidge and see if I get any good response out of that. I am going to adjust the timing a tiny bit right there. I'm going to take away some of the slope so that the changes hopefully aren't so drastic. So I flattened it a smidge. Let's see if we can get rid of that wiggle. Well, there's less of a wiggle. Still a smidge of a wiggle. It's not as sudden, but there's still a little bit of a dip there. Let's go back to that target area, see if it was timing related or not. And speed, here we go. It's clear, no knock or anything. Timing 6, 5, 6, 5, 6, 7, 8, 7, 8, 9, 10, 9, 10 and a half. You motherfucker. Yeah, it's still doing it. Calculated load is still bouncing around quite a bit. It's not as much. I'm not seeing 2.0s and 2.4s together, but I am seeing 3.5s and 44s. So it made a little bit of a difference. I'm gonna check cam timing too while I'm there. Make sure there's nothing in cam timing that's wiggling at the same time. That's pretty consistent. Yeah, not bad. Check boost real quick. I think we're just going to live with that tiny wiggle. It's about a 10 horsepower wiggle. But from red line to 58, I'm only dropping about 15. And for an FA, that's really damn good. Sometimes you get that range and they're dropping 50, and no matter what you do, you can't get it up. I appreciate you not taking that opportunity to comment about that. Let's see. All right, so let's see. How much room do you give? Yeah, so did you get my answer on that? Because I know we lost connection on that. It totally depends on how reactive the system is. Some systems, so ideally, like, okay, this system right now is nowhere close to being ideal. The fact that I'm reaching peak boost at like 20-something% wastegate duty cycle is absolute shit. That's not good in any way, of any sort, any fashion, whatever. That sucks. It sucks when you're playing with that much boost with that little duty cycle. It creates a system that's very, very unstable, very sensitive to temperature changes and load and everything else. And that's not ideal by any stretch, which is why I tell people don't put a boost control solenoid on a factory EJ turbo, because that's dumb. Because a lot of people will say, oh, it cuts your wastegate duty cycle down by half. Like, well, that's not a fucking benefit. Don't do it. Ideally, you want to have your peak boost happen, you know, in like 60 to 80%. And that gives you the ability to fine tune and tweak that boost really, really accurately all the time, regardless of weather, weights, how many people in the fucking car, whether you're going uphill, downhill, whatever. You have range, you can play with it. But if the system is overly responsive, you can't. You're kind of SOL. And so this 20% deal that I got right now in this one, I'm not happy about it, because it's going to mean that some days the guy's going to get 22, some days he's going to get 16, right? And that's not freaking ideal, but, you know, by any stretch. So anyways, that's my little bit on that. So how much do I leave available? And that depends on how sensitive the system is. That's a question I don't want to take away from the topic. Can I run the intake process on my JDM with 204 harness? No, you can't. The USDM is looking for a completely different trigger pattern. It's utilizing Hall effect sensors and all of that, where the JDM system is mag reluctor sensors, and like I said, different trigger pattern completely. You cannot do that. Yeah, or go to a full USDM setup, wiring and all that, but otherwise, no, you're not able to do that. All right. So I'm gonna call it here. There's only so much I can do with the boost control the way it is on here. I mean, I have so little authority on that. I think overall, I mean, the car was making 230 when it showed up, so jumping up to almost 300, that's an upgrade. And that's honestly what's crazy, but that's all from tuning. He was on an OTS map. I don't usually get that much from the OTS maps with tuning, but sometimes it's like 20. This one's almost 70. But the OTS maps aren't Cobb intercooler, and they're a different exhaust than this one. So like I said, it's really important that you follow the mod path that's listed in the OTS description, because you may be getting something that's not calibrated for what you got. I mean, like, check this out. So 299.8. Why do you keep doing that? Shut up. If I go back, see, to my runs, I'll do my last run yesterday, 325. Here we go. I'll do a couple runs. I have no idea how good they are. We'll load and close. So that's the tune as it came, basically, with that yikesness, and then mine with a teeny bit of that yikesness. But overall, I mean, okay, they got me right there. They beat me right there. I'm sorry, but yeah, I think the customer's going to notice, and I think the customer's going to be really pleased. And I think he's going to be excited that he got all this power from his tune. And with that, I'm gonna see that he's here, so you can He's here. Hey.
How you doing?
Good.
Awesome.
This is yours, right?
Yeah, yes, sir.
That's what I thought. I'm live streaming right now on YouTube, cool. So you're on camera now. Right on. So thank you for leaving your car here so we can do the testing on the intercool and everything. I did a couple hours worth of live stream yesterday on it. So if you were curious how your car did, it wasn't great. The intercooler did good overall, but I had my opinions and on it, that kind of stuff. So, and then that was the Cobb tune basically as it came on the car, and then this is as I finished it up. So gotcha. I'm pretty sure you'll feel that.
I think I will.
Yeah, I think you're gonna notice a difference there, and so I look forward to that. The install's not 100% done. He still has to tighten the main mount for the intercooler underneath. It was hard to get to. It's on the dyno still, and he has to change that. So we're gonna pull it out, stick it on the lift, and then he's gonna tighten the bracket.
All good.
And I think put your under tray back on, and that's it. So I'm done with the tuning.
Cool.
Yeah.
That's awesome.
Oh. Hey dudes, I'm done. Cheers. Hey man, how you doing? Say hi to the world.
Hey world.
I mean, there's 4 people, but it's the world. Yeah, you know, they're there. I do like coffee sometimes. So yeah, we just a reminder, Tanner. Just a reminder about the mount. We gotta do that. Okay. All right, well, I think that concludes my tuning session for today. Let me check if there's any last minute questions. You know, a little bit, like the parent inlet. So the factory one is pretty restrictive. Now, it doesn't affect the fueling because the mass airflow sensor is still fine, and because of that, it will compensate correctly for the increase in airflow. But what it does affect is your boost control. It reduces the amount of restriction on the inlet of the turbo, which changes your boost control, but also changes the efficiency of the turbo, which affects turbocharger loading and turbine drive pressure. So it does have an effect. So it's a good idea to get it tuned for. What parts does he have? He just got a turbo back catted exhaust system, Cobb intercooler, and Cobb intake. That's it. It needs a boost control solenoid to have better boost control for sure. And that's it. He did really good. Yeah, I mean, you know, you saw my base map was 40 horse above the other one, so it was a little more calibrated for what he had. Yeah, that's it. That's really all. And these things, even with some more mods, don't necessarily do a whole lot more than that. They just start to really choke out. You definitely get diminishing returns with this FA on the stock header and turbo. If you do just a turbo without a header, you don't get a whole lot out of them. Just more lag. I had like the Steam Speed turbo on here before, one of their ball bearing, their biggest one they offer or whatever. Yeah, it made less power than the stock turbo and lagged way more. It just wasn't a good balance. And part of that was also due to the header. The header is made really poorly on these. If you look inside the turbo flange, I'm not covering that again. Whatever. So if you look inside the turbocharger flange where the turbine bolts to the header, you see the welds where they weld the pipes onto it. On one of them, it's smaller. So one primary has a smaller diameter than the other one. Yeah, Chris, I can't tell you, man. I assume the Cobb, but I don't have back-to-back testing on, so I can't tell you, honestly. Yeah, actually, and this isn't even the test one. The test one was yesterday, and I covered a bunch of stuff with all the intercoolers yesterday with my experience of them. But as I covered also before in the 3 streams yesterday, I can't compare the two back to back because I've never had them back to back to test. I've compared them both to stock, and from my recollection, it feels like this one performed better. And actually, I think at the beginning of this stream or the last one, I said that I think the Grimspeed would be better for track and the Cobb is better for drag racing, based on what I recall about them. But again, without doing back-to-back testing on it, I can't tell you, definitively, which is better per se. And as I said before, for track, the stock one's better than this one. So it depends on what kind of racing you're doing and what you're doing with it. And that's my opinion. I believe this is better on the track than the factory one's better on the track than the Cobb one, because the factory one recovers almost instantaneously, and at high speeds, like it does perfect. It only really suffers at low speeds, and that's the difference, right? This one excels at low speeds, where the factory one suffers, and the factory one excels at high speeds, where this one suffers. So, yeah, I think that's it. So if that's all the questions, then thank you guys again for stopping by. I hope you have a great weekend. The guys at the shop are going to go do a meet in Seattle, Spring Fest or something like that. I was going to go, but I changed my mind. I am instead going to be spending time with the wife, and then I'm driving to California to pick up an STI. I bought another car, and I got below 10, so I had to buy another one. And so it's a 15 STI with 10,000 miles on it. It's got a build-it in already. It makes like 800 horsepower or something like that. I'm going to bring it here. I'm going to see what it makes on our dyno. And then I'm going to take it apart. I'm going to put my cams in it, because it's got S2s or S3s in it. I'm going to put my cams in it and see the difference. And then I'm going to take it all out, return the car to stockish, stock motor and everything else, and then probably sell the car, and the build with some modifications will be going into my hill climb car, and some of it's going to get sold to some friends and family and people and whatever, and then but a bulk of it's going to go into the hill climb car, so it'll be a lot of fun. Thanks again, guys. Have a good weekend.